Now let's continue on our discussion with acids and bases. And what I'd like to talk about in this video is one of the two approaches we have towards looking at and comparing the acidity of acids and bases. And the first approach I'd like to talk about is a quantitative approach, or coming from a quantitative perspective. And as a quick review, let's just recall that the value of our Ka from our general and high school chemistry measures the strength of the acid. Strong acids have a very high Ka, and that means that essentially weak acids have a very low Ka. And now, since these values are typically super large, so for example 10 to the power of 10 or super small 10 to the power of negative 50, we often like to express them in a notation called pKa. So pKa is just taking the negative log of our Ka. And what this relationship will do now is basically help bring these numbers down. So typically the range of the numbers is probably going to go from, now instead of being very high and super low, probably from, let's say, about negative 10 to positive 50. And now what this basically means is this logarithmic relationship basically makes it so that now an acid with a low pKa is strong, and if it is a high pKa, then it is weak. So that log relationship makes the numbers smaller to deal with and kind of inverses everything. So now if you have a low pKa or a high Ka, you have a strong acid, and if you have a high pKa or low Ka, then you have a weak acid. So that was kind of the very brief overview that I wanted to do. And as a quick example, what I'd like to do now is, as we can see, we have two compounds here, and I guess just for knowledge purposes, this is acetic acid and this is acetone. And again, if you're not quite familiar with nomenclature, we're going to get to that later on, but I wouldn't really want to focus my attention to that. What I want to focus on are these numbers. So the pKa values I have listed over here. So this has a pKa of 4.75 and this has a pKa of 19.2. So which one is the stronger acid? Well, as we talked about previously now, the stronger acid is the one with the lower pKa. So this acetic acid is much stronger than this. And what I'd like to remind you is, if we have a stronger acid, so the stronger the acid, then the weaker its conjugate base. So that's kind of the relation, and vice versa again. So if you have a weaker acid, then its conjugate base will be much stronger. So based off of that now, if we know that this is our stronger acid, which means it's more acidic because of its lower pKa, and this is the weaker acid, we know that this will produce a weaker conjugate base, and this will produce the stronger conjugate base because it has a weaker acid. So sometimes these kind of questions make as good multiple choice questions, and sometimes there can be a trick. It could ask you, hey, what is the stronger base? And then what you have to recall is that the weaker acid produces a stronger base, so it would be this in this case. Now this qualitative approach we talk about is it's not used as extensively as the other approach that we're going to talk about in the next video, but it's good to mention this now. And as I will say, pKa values should be given to you, or there should be a table that's given to you, and typically you're going to have kind of a table where the numbers at the top will be the stronger acids, and then the things at the bottom will be the weaker acids, and there'll be pK values increasing as the table goes down. And usually you can find this online or in various organic chemistry textbooks. So now that we kind of have an understanding of this quantitative perspective when we have data given to us, such as pKa values, the last thing I'd like to talk about in this video are pK values predict the position of equilibrium. Now, as we can recall, a common misconception of the word equilibrium is that people often kind of mistake it and assume, oh, this means that the concentration of the reactants and the products in the reaction are the exact same. And I'm going to stress this even more. That is false. Equilibrium means the rate at which a reaction is going in this direction and in this direction is the exact same. So make sure you remember that. And now these pKa values in this quantitative perspective can really help us with our position of equilibrium. So something I'd like you to note, and which you should put in your memory banks, is that equilibriums in any acid-base reaction will always favor the formation of the weaker acid. So essentially, that means you compare the acid and the conjugate acid on both sides of the reaction, and whichever one has the higher pKa value, that's the side equilibrium will favor. So I'm going to do one quick brief example. And here we have this, and you might be wondering what this funny little box is. Well, that's where we're going to put our equilibrium arrows after we determine what side equilibrium favors. So here, once again, these values are given. So I automatically know that from the last video, if I look over here and I look over here, this is gaining a hydrogen, so this has to be my base, and this has to be my conjugate acid, and then this has to be my acid, and this has to be my conjugate base. If you don't quite remember how to do that, I strongly recommend looking at the last video. So now we've determined our acid and our conjugate acid. Now sometimes if these pK values aren't given to you, you can look them up on a table, but typically in a question like this where they want you to use the qualitative perspective, pK values will be given to you. It's just a matter of understanding the relationship of the pK values. So what side forms the weaker acid? Well, it's going to be the product side because this has a higher pKa than this. So that means that equilibrium is going to favor my product side. And here now I'm going to explain why I made this kind of box, because if you put equilibrium arrows like this going in the direction forward and backwards and they're the same, so something like this, that's going to be wrong, because what I want you to do here is kind of show what side equilibrium favors, and you always make the side equilibrium favors that half arrow longer. So since the product side is what's going to be favored and the equilibrium is going to proceed to the product direction, or in otherwise this direction, we should make this half arrow longer and this half arrow that's going the other way shorter. So this shows us that yes, indeed, equilibrium favors the right side because this has a higher pK. And that's all I really wanted to talk about in this approach. We're not really going to study this extensively. The other approach, then in the next video, we're going to study in much more detail because that is something that's more asked. So that's it for this video. Any questions, comments, concerns, feel free to email me or comment down below. And don't forget to rate, comment, and subscribe. Thank you.